In this video tutorial, we are going to build the diagram that you see on your screen. This is a lane diagram with 6 lanes. All layers render nodes. Nodes in the first lane contain images. Then we have nodes with text, and then these nodes that look like arrows. The interesting feature is that links change their color when they cross lanes. Also, new nodes created in each layer take the shape and color of the other nodes in the layer. We create a new WPF project called Lane Diagram. From the toolbox, we drag and drop the diagram control. We have installed MindFusion WPF pack, and the UI controls are available in the toolbox. Let's give the diagram control a name so we can refer to it in source code. We call it diagram. Then in the CS file, we add references to the diagram namespaces that we will use. We set 2 properties to the diagram. Auto resize is none, and we enable in-place edits. This means that we can edit nodes interactively. If we run the application now, we can see that we already can create, edit, and connect nodes. This functionality is provided by the diagram control. We initialize a header variable and we get the lane grid of the diagram, which we store in a variable called grid. We set some properties on the lane grid. The header should not be on top. All column headers have the negligible height of 5 points. Cells should not be aligned, and we allow the user to resize the headers interactively. We get the column headers collection for this grid. Then, we add, one by one, 8 headers. These headers are not used by our application, and that's why they are only 5 points high. But we need them to divide the lane grid into columns. We give each column 140 points width. We apply some styling to each header. You can see the styling properties in the online documentation for the WPF diagram. We make the borders of these column headers and their background transparent. Now we will build the lane rows. We initialize a list with the row header titles. One of the titles is an empty string. This is the lane that will hold the labels rendered under the images. We create 6 headers now that we add to the row headers collection of the grid. The header constructor takes the label as a parameter, and we take the subsequent value from the lanes array. We make the header bold, the width is again 150 points, and the height is taken from the heights list. About the styling, if you look at the final application, you will see that the last two lanes are with gray backgrounds. That is why we style the 5th and 6th lane with a different brush. Let us enable lanes for the diagram and run the application. The diagram area is now divided into lanes. The last two lane headers are gray, but let us add a scroll viewer to the application so we can scroll and see them. Here they are. Now we will style these cells in the lane. We cycle through all rows. Note that we can access these cells in the grid as items in a list via square brackets. What is important also is that when we don't provide a particular number for the column index, the object that is received refers to all cells in the row. So we make the first two rows with a gray background and add a thick right border. To the other rows, except the last one, we add a thin bottom border, which will be the divider line. Here is how our application looks now. We will create a new folder called Images, where we will copy the 8 image files that we have chosen for the application. Then we need to add them as items to the application. Let's check. They have their build action set to resource, and that is fine. We add a list with the names of all those files. We then cycle through all 8 columns and get the bounds of each cell. We use the getCellBounds method of the lane grid, which is a really useful one. It gives us a rectangle that represents the coordinates of the cell. We use this rect to create a rectangular shaped node and assign an image to its image property. We use the tag property of diagram item to keep the lane index for the shape. This is the first lane, so the tag is 0. Let's try the application. Here are the images, which are actually transparent nodes, which hold images. As you see, we can connect them, move them. Now let's add those labels that render under them. We create a list with the labels and cycle again through all 8 cells on the second row. We get the bounds of each cell and use its text property to assign the label text. If you look at the members of the Shape Node class, you can see that there is an impressive list with properties. We use here the text property, also transparent, and in these nodes we also use font size. Here are the nodes. Now we will create the red nodes beneath them. We create them in absolutely the same way we created the nodes from the previous row. We cycle through all cells in the row, get the cell bounds, and then adjust them. The nodes on this row have bounds slightly smaller than the cell bounds. It is interesting to note how we decide which shape to use for the new node. You can see all shapes in the table of predefined node shapes in the online documentation. Here we have chosen arrow 7 as the first shape on this row, and the others are ISO process. We use the same text property and the tag property, which we set to 2 because this is the third row. We also use a new property, the ID property. We will assign the text to be the ID. We set the brush and stroke properties of the node to red brushes, and the text brush is white. If we run the application, you can see now the new row of shape nodes. We can interact with all nodes in the diagram. However, you can lock them with the locked property and the user will not be able to modify them. We will add now the nodes for the fourth row, which we do in the same manner. The difference is that they are red and their shape is always a rectangle. We use the same properties for styling, brush and stroke, as well as the text, ID, and tag properties. The tag shows the lane index, the ID is the same as the label. Now if you look at the final version of the diagram, you will see that some cells contain two label nodes, and also the nodes are not always located inside a cell. This depends on the links that connect to them. So, we will add now the connections between the rows on the two last rows. We make the connections the following way. We get the nodes that we want by using the findNodeById method. This is why we wanted to have the label of each node set as its ID. After we found the nodes, we use the createDiagramLink method of the factory class to create the link. The factory class is available as a static property of the diagram. Now, as you see, we have the link. We create the same way all links. We can arrange now the nodes based on the links that connect them. We stored the nodes from each row in an array called lane nodes. We provide this array as a parameter to a method called arrangeNodes. In it, we look at each node and check the number of its incoming links. We use the origin and destination properties of the diagramLink class to get the nodes on the two sides of the link. Then we can get the bounds of the nodes and change them if necessary. If the node has two incoming links, we center it relatively to the nodes from which those links come. If the incoming link is just one, we check where the origin node is located. We use for this the tag property, which, as you remember, stores the row index. If the node is in the same row, we need to shift it downwards. Now if we run the sample, you can see that the nodes are well positioned. We repeat the same process for all remaining layers and all nodes in them. We create the nodes and add them to an empty list. We give each node an ID that is the same as its label. Then we connect the nodes with the createDiagramLink method of the factory class, and then we arrange all nodes in a layer with the arrangeNodes method. The nodes are well arranged now, but we need to work on the links. First, we will make sure they have the right shape. We arrange the links with the help of the orthogonalRouter class. This is a layout algorithm that is applied on links after nodes have been arranged. Exactly our case. Links are well arranged now, and we can start painting them. The effect that we want, different colors for different segments of the link, can be achieved only through custom drawing. We cycle through all links, which the links property of the diagram conveniently provides, and we set their custom draw property to custom draw full. This means the control will not paint any part of the links. We must do this. We add a new method called pointInSegment. Its aim is to return the index of the lane where the given point is located. It gets the bounds of the first cell in the lane and checks if the provided point is inside this interval regarding its y value. Then we add the getLinkSegments method. It receives as an argument the collection with all control points of the link. There is a property that gives us the collection, and we'll look at it later. We check which are the segments where the first and last point of the link are, which means the two lanes between which the link stretches. Then we cycle through all segments between them and check if the consecutive control point of the link is inside a segment. If it is, we add it to the result array. Before we go to the next segment, we add the border point to the segment points. This method actually inserts the points that lay at the border between two segments to the list with control points of the link. Now we will handle the draw link event, where we will actually paint the links. In the event handler method, we initialize a list with the brushes that we'll use. The first two brushes are black. We don't need them. Let us look again at the final diagram. So, we need a pink, a red brush, and two gray brushes. We add them in now the painting. We get all link segments, including those that mark the segment borders. We use the points property of the drawLinkEventArgs class that comes as a parameter in the event handler. This is the argument that we supply to the getLinkSegments method. We draw rectangles that represent the link segments using each pair of consecutive nodes. We take the brush from the brushes array according to the lane index. You can see that the links look good now. There is one problem, however. They are drawn at the top of nodes. We can easily correct that. We will set their z-index to a small value, which guarantees they will be drawn before the nodes. Each diagram object gets an incremental z-index when created. Thus, the 100th diagram item will have a z-index of 100. Now the application looks well. Links are drawn the way they should. There is one more thing though. If we draw new nodes or links, they still have their default appearance. Let's change that. We will handle the node created and link created events to achieve the desired result. In the node created event, we initialize the lists with the brushes and strokes that we want to use for the new nodes in each lane. We get the node property of the node event args parameter and we get its bounds. We use our method pointInSegment to get the index of the lane where the top left edge of the new node is located. Then we can get the correct brush and stroke for it. We also assign it to the right shape. All new nodes, except those in the third lane, are rectangles. If we create new nodes, now you can see that they have the correct shape and color. While you draw them, the diagram renders the default mode. This can be changed by handling the node creating and link creating events and is done in the final version of the project. Now if we run the application, you will see that newly created links get colored the same way as the rest of the diagram. With that, our video tutorial is finished. You can find a link to download the source code of the whole project in the video description. Thank you for watching, and thank you for your interest in MindFusion Developer Tools.